Okay, so why should you build and test your Solidity project entirely in Solidity? Now I'm going to open myself up right away and reveal that I don't understand the counter argument for this on any level. I don't know of any language where developers develop the code in one language and then they develop the unit tests in another language. And I could almost imagine myself in a situation having, engineering experience in large corporations. Imagine I'm working at one of these 3-letter acronym corporations, and I go in to a developer team meeting, and I say, hey, we're going to build this project in Python, but we're going to develop the unit tests in TypeScript. And in that scenario, I just imagine myself being laughed out of the building, right? I mean, it's such a preposterous proposition that you would almost think that would put my career at risk, that people would identify me as being potentially not rational or totally and completely misunderstanding the point of unit testing being this immediate feedback mechanism where you get thoroughly integrated and highly connected feedback for your code. And then fast forward 10 years later. So we have an environment. And this really is a development environment that's just coming into existence. So we have a brand new development environment. And it just so happens that that environment is being, mainly built by people who are TypeScript programmers. So this video is really aimed at people who are currently using Hardhat or are starting a brand new project in Solidity. Perhaps they're targeting an EVM compatible chain and they want to write a contract. So why should you test in Solidity? Well, so let me give you some reasons. Reason number 10 is community support. So if I'm building tests in Solidity, then the entire Solidity community is there for me as a support structure. I can go and ask for help in Solidity forums. In my public source repositories, I can get feedback from the community. And it makes sense that the Solidity community participates in my project, especially if we're talking about developing a smart contract. Number 9, refactoring benefits. So if I'm developing a contract, one of the reasons why we want to develop unit tests is because the unit tests expressly test the API implemented by that contract. And even beyond that, not only do they test it, but even when you're compiling the code, there is a check that the specific API that's being called exists in the target code. So it completely makes sense that these two things would be in the same language because there's a calling convention for the language. And the language and the tests should match the calling convention for individual contracts. If this is being translated into an ABI specification and then you're calling through based on that, then there's a level of indirection. Your tests are not necessarily going to fail when the API differs. And in fact, this could lead to bugs. We could imagine that, the API changes over time. And some APIs, some tests, maybe test a particular API when they should test, a more modern API or vice versa, that there's not compatibility enforced at the compiler level. The next reason I'm going to put out there is test execution performance. If we have a high performance test framework that uses compiled code to simulate an EVM and run these tests, you're going to get better performance than using an indirect service that boots up and connects through an RPC client. This obviously is something that will enable testing long term. It will improve the quality of the experience for the developer. And really, for unit testing, the name of the game is fast feedback. So we should get the fastest possible feedback. We should not be delayed in our test process. Our CI/CD should not be slowed down because the tests take a long time to run. Okay, now I'm going to bring up a sensitive topic for most developers. Number 7, documentation. When we're developing public source code, we should always be producing documentation. Now, if I'm developing this test in TypeScript, there's really no Solidity-based or Ethereum-based mechanism to convert this test into any form of documentation. This really just represents kind of like a straight up API check, sanity check. However, not only can I use the mechanisms of Solidity to document my Solidity-based test, but also the test itself, if I want to figure out how to change ownership, can serve as a form of documentation to developers. So this is an excellent way to learn the package, learn the contract, learn how you should be using it, and then what happens when I use it in a certain way? What happens when I use it in a different way? Are there problems if I do, something the wrong way? What problems should I expect when I'm doing it in those ways? So this all becomes a form of documentation. The next thing I'm going to suggest, number 6, is consistency. Now, I've spent a fair amount of time developing Solidity, and I've also spent a reasonable amount of time developing TypeScript, and even other languages beyond that. I have decades of programming experience. And what I can tell you is that there's differences in the code style between TypeScript and Solidity. And one of my pet peeves is when I see Solidity written like TypeScript, right? What it's telling me is that programmer is not experienced enough with Solidity to know the conventions and the norms that engineers are using. There's a difference in the spacing. There's a difference in quoting. There's a differences in, how we call something and, where names go and what things look like. There's a difference in name spacing and how names work in Solidity. So it's very hard to have consistency across languages when my tests are written in 2 different languages. And it's really putting a burden on the engineering team to understand what these differences are and to get it right. Because it's natural for engineers to follow the same pattern and habits and rituals and to try to end up using the same consistency. And even though we have tools that check for these inconsistencies, really the engineer at some point is going to be responsible for creating a consistent code style across all the code. And we should enable that by just using the same conventions and norms in our tests that we use in the code base itself. Another topic that's really an important issue, number 5, debugging. So I would ask you, how do you even debug this? It's not possible, right? Because it's across a network, and it really doesn't give us any facility for debugging as is customary in most programming languages, right? We really want to be able to boot up the stack, set a breakpoint at a particular location, and run to that location and see what's happening inside the EVM to know what's going on. So this is very challenging to do if our tests are not written in the language that we are accustomed to using for our contract. On the other hand, debugging is so much easier. when we're working in the same language. And you can not only do interactive debugging, which is very useful, but you can also use other debugging strategies. For example, printf debugging, where we insert log statements or console statements at various points in the program and see what's going on. And although you can do that in the TypeScript realm, again, it kind of gets back to this consistency problem, because what will happen is if you put any of those kinds of statements in your contract that's under test, you may not see them depending on how you're emulating the virtual machine. It's not going to be a consistent environment that's running everything. You would have a different way of introducing log statements in the TypeScript as you would have in the contract itself, and you're not going to see consistency across those different layers to be able to use the same techniques. And really, when we are injecting a log statement, we want this to be just a one-liner that we can immediately delete as soon as we've confirmed the information we need to know is there. How are you going to do that if you're working across all these different layers? It becomes confusing and difficult. So your debugging workflow is kind of terrible if you're not using Solidity. Now, another problem that I want to bring up, and this is a very serious problem when we're developing contracts. Number 4, security. Developing tests in Solidity enables us to use the specific calling conventions of the EVM to challenge our contract under test. We can expect a revert. We can change the ownership of the caller, right? We can set the caller to a certain address so that we can test all of the specific actions that could occur in our contract. And all this is possible in TypeScript testing. It's much more clean and clear what's actually happening when we do it from the Solidity perspective. And there's other types of tests that are not possible at the TypeScript level, such as fuzzing or time-based tests, that are really enabled if we're working fully in Solidity. So we can have a better understanding of our security model, and we can create better unit tests that check for the security requirements of our contract by using Solidity. Number 3, code reuse. This is one of the fundamental reasons for program modularity. This is why contracts exist in the first place, right? That we can write reusable libraries and digests of our code that we reuse across all the different layers that anyone can use, and we know that they're safe and we know that they're tested, right? Rather than copying and pasting code across every test or every contract, we can use the same module and incorporate information from other places or library code from other places that enables our contract to be consistent and well-tested and hardened by the fact that this stuff is just used everywhere. It becomes a normative convention in calling it, and we enable reuse because the programmer is just writing this code one time versus every time we write a test having to generate up some customized code to translate across different layers. We would end up actually having to, at a minimum, implementing many routines twice if we're using 2 languages, right? Because the first thing has to be implemented at the Solidity layer, but then also its partner or its connective tissue needs to be implemented at the TypeScript level. And so it really doesn't even make any sense from a code reuse perspective to be using 2 different languages. That's going to actually double up our work. Number 2 almost goes without saying, but seamless integration. Think about this. The same compiler that compiles my contract can compile my tests. That makes a heck of a lot of sense to me. That makes a hell of a lot of sense to me. Why would I have 2 compilers in my workflow? Why would I have 2 full runtime environments for my programming languages in my workflow? Why would I have to marry together 2 disparate runtime environments from different and inconsistent systems in order to be able to test my code? How many bugs, how many problems, and I have to say, the way that Hard Hat has worked and the stability of it, it's clear that they've gone to heroic levels to get this even to work in the first place. But in my opinion, the fact that nobody sort of took a step back and forced the issue and said, we have to have tests written in Solidity is an evidence of the immaturity of the system. And the fact that we can do that now is a huge innovation in smart contract development. This is game-changing. And I think the only reason that people didn't kind of pump the brakes and demand Solidity testing is many of those implementers were TypeScript programmers. So they had a hammer and they saw every problem as a nail and they just went for it. But we don't have to live like that now. We can actually develop our code and our tests in Solidity. And then finally, the number one reason, and this should just go without being said, and it's tantamount to everything that I've been saying so far in this whole discussion. Developer familiarity with the Solidity language. First of all, we hope that developers who write smart contracts are experts in Solidity. But we know that we're all learners, right? Every single one of us is improving our skill set. Well, what's the best way that anyone can think of to improve their skill set, right? That's to practice. No matter what we're talking about, no matter what tool or technology, we should practice with it to improve. Well, if you're writing tests in TypeScript, you're not practicing your Solidity skill set. And in fact, this is probably even more true of other languages, where in Solidity, you're actually programming the behavior of an EVM. So you really have this kind of connection between the Solidity code and the behavior of the EVM and the stack machine and the calls that you can make, the specific function calls that are allowed. And those two environments, runtime environments, let's call it, are radically different across TypeScript and Solidity, or the EVM. Whereas TypeScript offers a super fluid and flexible runtime environment that is very rich and powerful, Solidity offers a very statically typed, fixed, and kind of constraining runtime environment that limits your behavior, it limits the things that you can do, limits the type of operations that can happen. So really, at the test level, it gives the best advantage to contract engineers to be able to learn, actually, the nuances of how the EVM works and how it works specifically with your code. And it also gives you the ability to write little experiments and toys. Say you don't understand the behavior that's going to happen if the owner, is A or the owner is B, right? A test is the perfect way to diagnose and gain that understanding. And really, this one reinforces all the others. So in my mind, it's a no-brainer. If this is 2023 and if you're developing smart contracts, you should be developing tests in Solidity.